Example 2, Part A. It's given that angle FEJ equals 25 degrees. FEJ. Measurement of angle FGJ equals 57 degrees. FGJ equals 57 degrees. Find measurement of angle GFJ. GFJ. So this angle right here. Measurement of angle FGJ equals 90 degrees by the kite diagonals perpendicular theorem. Measurement of angle GFJ plus measurement of angle FGJ equals 90 degrees by the acute angles of a right triangle are complementary. Measurement of angle GFJ plus 57 equals 90. We substituted measurement of angle FGJ for 50. And then we minus 57 from both sides for our basic two-step equation to get 33 degrees. So measurement of angle GFJ equals 33 degrees. Done. Okay, this is example 2, part B. We have to find measurement of angle JFE. This angle right here. Triangle FJE is also a right triangle. So this is now a right triangle. Measurement of angle JFE plus measurement of angle FEJ equals 90 degrees. So I'm going to substitute 25 degrees for measurement of angle FEJ. So measurement of angle JFE, that angle, plus 25, which is FEJ, this angle, equals 90 degrees. So I'm going to do minus 25 on both sides, and I get measurement of angle JFE equals 65 degrees. This is example 2, part C. We need to find measurement of angle GHE. GHE, so this angle right here. Angle GHE is congruent to angle GFE by kite to one pair opposite angles theorem. Measurement angle GHE equals measurement of angle GFE by definition of congruent angles. Measurement of angle GFE equals measurement of angle GFJ plus measurement of angle JFE by angle addition postulate. Measurement of angle GHE equals 33 degrees plus 65 degrees equals 98 degrees by substitution. So measurement of angle GHE equals 98 degrees.
A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called a base. The non-parallel sides are called legs. Base angles of a trapezoid are two consecutive angles whose common side is the base. So here we have our base, and then here are the legs, and then the base angles that share a side with the base.
Now we're learning about isosceles trapezoids, your theorem 6-6-3. Now, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So, the isosceles trapezoid means base angles are congruent. So, angle A would be congruent, this angle A, be congruent to angle D. And angle B, this one, would be congruent to angle C. So angle A would be congruent to angle B or angle C, but angle A would be congruent to angle D. And angle D would be congruent to angle A, but angle D wouldn't be congruent to angle B or angle C. And angle B would be congruent to angle C, but it would be congruent to angle A or D. So angle B is not congruent to angle A or D. And angle C is congruent to angle B, but angle C is not congruent to angle A or D. So basically, these two are congruent, but no others are congruent. So, this is not congruent to this, this is not congruent to this, and this is not congruent to this, and this is not congruent to this, and that's it. Alright, so now we're doing 6-6-4 on the theorems for isosceles trapezoids. Now, if a trapezoid has one pair of congruent base angles, then each pair of base angles are congruent. So, if it has base angles, then they're both are congruent already. So, trapezoid's pair of base angles are congruent. That means it's isosceles trapezoid. So, when these two are congruent, it means isosceles. So, these prove that ABCD is isosceles. These are two are parallel, these two are congruent because it's isosceles. So if these two were not to be congruent, if these two were congruent to angles, then would it be isosceles? Therefore, it is isosceles. So now we're learning about 6-6-5 on our isosceles trapezoids. Now, if the isosceles trapezoid is diagonal congruency, then AC would be congruent to DB. And we know they're both congruent. ABCD is isosceles, proven because these two are congruent. If they weren't congruent, then wouldn't it be isosceles? So therefore, it is isosceles. Because D is congruent to B and A is congruent to C. And these two are parallel, these are congruent. These two lines right here, AB and DC, always have to be congruent, or it's not isosceles. So things that make the trapezoid isosceles would be AC be congruent to DB. Was congruent, therefore it's not isosceles trapezoid.
Guys, this is example 3 of lesson 6-6. We are finding measurement of angle Y. This angle right here. Measurement of angle W plus measurement of angle S equals 180. So measurement of angle W plus measurement of angle X equals 180. 117 plus measurement of angle X equals 180 degrees by substitution. So measurement of angle X equals 63 degrees. Angle Y equals angle X by the isosceles trapezoid base angles congruency theorem. Measurement of angle Y equals measurement of angle X by definition of congruent angles. Measurement of angle Y equals 63 degrees by substitution. So this is your answer.
Longer. Keep the clock 5 more seconds.
Why did you do that?
So that way hand. Okay, this is example 3, part B. We're finding PS. RT equals 24.1 degrees. So this RT, this segment right here, equals 24.1 degrees. And QP, segment right here, equals 9.6. QS is congruent to RT by the isosceles trapezoid diagonals congruency theorem. So this segment is congruent to this segment. RS is equal to RT by definition of congruent segments. QS equals 24.1 degrees. So this segment right here equals 24.1 by substitution. So QP plus PS equals QS by segment addition postulate. 9.6 plus PS equals 24.1 degrees by substitution. So therefore, PS equals 14.5.
This is example 4, part A. So we're finding value of Y so that EFG is isosceles. So angle E is congruent to angle H because it's trapezoid with a pair of base angles. It's congruent, so it equals an isosceles trapezoid. So measure of angle E is congruent to measure of angle H because of the definition of congruent angles. Excuse me. 2y squared minus 25 equals y squared plus 24 because of substitution. So y squared equals 49 because we subtracted y squared and added 25. So y can equal 7 because 7 times 7 is 49, or y can equal -7 because -7 times -7 equals 49.